Sir, I'm doing good.
So do you have a test coming up soon, or?
Yes, sir. I have my exam coming up.
Is it next week or is it this week?
Yes, sir. My math exam is this week.
This week. So we won't have sessions next week.
No, sir.
Okay. And finally, we're looking at difficult trig problems. And
Yes, sir.
when I say difficult, I really mean the sum to product and product to sum. I don't get a whole lot of students that do that. Primarily because it's not so much needed until you get to calculus. When you get to calculus, product to sum is very valuable because it allows you to integrate certain functions. But at this level, I guess they're just preparing you for calculus. Let's start it. Should we start at 1?
Yes, sir.
Okay, how am I going to do number 1?
All right. So 5 times the cosine of x is equal to 1.
Yeah, you're going to need your calculator on a lot of these.
All right. Just got my calculator.
I guess, what's the initial step you're going to do here on number 1?
Divide by 5.
So we have cosine x equals 1/5.
So we have the inverse cosine of 1/5.
Exactly.
So that's around 78 degrees.
Okay. Now, do they care if your answer is in degrees or radians here?
Ooh, I think they want it in radians.
Do they? They don't necessarily say that. But that's okay. Your calculator will give it to you in radians. If you put it in radian mode, then take the inverse cosine of 1/5.
Yes, sir. Let me. Radian mode. Let's see.
What do you have? A TI-84?
Yes, sir. A TI-84.
Okay. That's a good one to have. It's easy to convert between radians and degrees on that one. Some of the higher ones, it's a little tough to do it, believe it or not.
Yes, sir.
So what do you get for x?
Wait, do you know how to switch between radians? Because I'm not too sure about that.
I do. If you go to function.
Okay. Function.
I think it's the function key. Hold on, let me pull out my calculator. I have a TI-84. It's actually mode, not function. It's mode.
All right. Mode.
Click on mode.
Oh.
If you go down to 4, you'll see radians or degrees.
Okay.
Put it on radian.
All right. It looks like it is 1.369 radians.
Okay. Is there any instructions on rounding off with these problems?
No, sir.
Okay. Now, that's actually, given the problem, that's not the exact answer. What is the exact answer? In other words, that would be the answer inside the unit circle. It would be 1 up. But they have not restricted the domain to be from 0 to 2 pi. So it's this answer.
Yes, sir.
Plus k 2 pi. And notice something else, is this answer is only 1 quadrant of the unit circle.
Yes, sir.
What other quadrant is cosine positive?
Quadrant 4.
Correct. So you have to take 2 pi minus 1. Well, let's see. Hold on a second. What was that in degrees? That was like 78 degrees?
Yes, sir. I think I'm just going to keep it in degrees. I don't think it really
Yeah,
matters.
that's fine. We can always convert it at the end. So if 78 degrees is one answer, what is another one inside the unit circle?
So that's going to be 78 degrees plus 180. Okay, so is that going to be 258 or
82, I think. Hold on, am I doing my math right? It's
well?
360 minus 78.
That's right, 282.
282. In other words, that's the fourth quadrant angle, where the cosine of 282 is a positive 1/5, and the
Yes, sir.
cosine of 78 degrees is a positive 1/5. So those are the two angles in the unit circle, but they don't restrict this to the unit circle. So your answer is 78 degrees plus k times 360, all multiples, all coterminal angles to that, and
Yes, sir.
282 plus k times 360. And
Yes, sir.
if you were in radians, you just replace the 360 by 2 pi.
Yes, sir.
In other words, it's 78 degrees plus 360. So 438 would give you cosine equal to 1/5. I could add another 360 to it. I could subtract 360 to it. All of these multiples where k goes from negative infinity integer to positive infinity integer.
Yes, sir.
And if they don't restrict the domain, a lot of these problems, they'll restrict the domain from 0 to 2 pi. So you would get away with only giving those two answers.
Yes, sir.
But this one doesn't say that, unless it says it above where I'm able to see. It doesn't say x is between 0 and 2 pi.
No, sir.
Okay, so you have to give all the answers. And that's where this notation, you're familiar with this notation, right?
Yeah. Yes, sir.
Not everybody uses k, some people use n, but basically k is all integers from negative infinity to positive infinity.
Yes, sir.
All right, let's go on. Number 2, how am I going to do number 2?
So that is the sine squared of x minus 7 sine x equals 0. Is that where we would use the sum the product formula or not?
No. Think of this, whenever you see this, think of quadratic.
Okay.
This is
So that
quadratic in sine x. In other words, it would be very similar if I had x squared minus 7x equals 0. This is a quadratic in x. So we solve these the same way. In other words, you would solve this one by factoring out an x.
Yes, sir.
Okay, do the same thing over here. What are you going to factor out?
All right, so sine of x.
Leaving?
Sine of x minus 7.
And now, just like a polynomial, you're going to solve it by setting each one equal to 0.
Yes, sir.
So sine of x equals 0. Where does that occur?
90 and 270. And then each.
That's cosine of x. Sine of x is 0 at 0.
0 and 180.
Nope, just 0. Nope, my mistake. 0 and 180, absolutely. Okay, which means this answer is x equals 0 plus 360k, or x equals 180 plus 360k. So that's the two answers you get from this part. What
So
about
we
the
can't
second
say.
part?
So we can't say 0 plus 180k.
Yeah, I guess we can, now that I look at it. This is one of the few times where you can probably define it singularly with one row only. Yeah, I believe that does cover all of the angles. You're right. It is 0 plus 180k. That gives you the same answer as those two rows.
Yes, sir.
Doesn't always. When you find it in different quadrants, like the last problem, couldn't do that. I had to give the answer as two different answers.
Yes, sir.
Okay. How about this part here?
All right. So sine of x is equal to 7, and that is no solution because the sine cannot be greater than 1. Is that right?
Or less than minus 1. If I
That's
draw
right.
the sine curve, here's what it looks like.
Right, right.
Never greater than 1, never less than minus 1. So when you get sine of an angle equals a number outside that range, you know there's no solution.
Yes, sir.
Okay. Let's go to 3. Similar problem.
All right.
It's
So 2 times.
It's a quadratic in secant x.
All right. So we would factor it out.
Okay.
So we have the secant x times 2 times secant x minus 3 is equal to 0. So secant x equals 0, and 2 secant x equals 3.
2 secant x equals 3, so secant x would be equal to 3 halves.
Yes, sir.
Did they do that right?
That's right.
Is this possible?
That is the secant x equals 0.
Okay, we'll start there.
All right, so
So
secant x
secant
equals
x
0.
equals 0. Where does that occur?
1 over cosine x equals 0. So that's where the cosine is undefined.
Correct.
So that is 90 and 270.
No, cosine's defined everywhere. Here's the cosine curve.
Oh, that's right.
There is no place the cosine is not defined.
That's right. Only the tangent. I was thinking of the 0 values and if they were flipped upside down. Wait, the secant. The secant.
The secant sits on the tops of the cosines. In other words, here's what the secant curve looks like. Tops and bottoms. The blue is the secant curve. And the reason you know it has to be the same as that point right there is because when the cosine is equal to 1, the secant is the reciprocal, so it has to be equal to 1 also. Or if the cosine is equal to -1, then the secant has to be equal to -1 at that point. So
Yes,
tell me where the secant is equal to 0 based on my graph.
it is not.
Nowhere. That's impossible. Okay. So the second one says secant x is going to be 3 halves. Well, that's at least in our range. So how would you solve that on your calculator?
So we could just enter the inverse.
Yeah, you don't have a secant on that calculator.
So we could do the inverse cosine of 2/3.
Perfect. Exactly right. Inverse cosine
and we get around
2/3. What does that give us?
around 48 degrees.
else?
So that would be 312.
Huh? Now notice in this one, I cannot write it as one row. Because
That's right.
it's not a difference of 180.
Yes, sir.
Okay, so I've got to write it like this. X is equal to 48 degrees plus K 360. Or X is equal to 312 degrees plus K 360. And you can use radians or degrees here. In other words, if you had your calculator in radians mode, you'd get a number instead of a degree. And it would just be that number plus K times 2 pi.
Yes, sir.
Okay? But you'll notice there's no way to put that into one statement.
Yes, sir. Because there's not a difference of 180.
Yeah, it's only when there's a precise difference of 180 that you can kind of simplify it into one statement.
Yes, sir.
All right. Tangent squared x minus 5 equals 0. So what does that mean?
So the tangent squared is equal to 5.
What's the tangent?
So tangent is positive or negative root 5.
Okay. Fine.
So,
and here, you know you're going to have all 4 quadrants, right? Because if
yes,
I didn't have the plus or minus, I know that I would have 2 quadrants, first and third.
Yes, sir.
The minus also gives me the second and fourth. So let's start out with the first, which is what the calculator is going to give you only.
The tangent of root 5 is approximately 65.9, so 66 degrees.
And where else?
So if it's going to be all 5 quadrants, all four, good grief. 156?
Hold on a second. And, yeah, give me the second quadrant where it's positive root 5.
Where it's, okay, so that's going to be the third quadrant, so 246.
Okay. Now those are separated by 180.
Yes, sir.
And the second quadrant is what?
156.
No, the second quadrant would be 114.
Because there is
supplementary angle to 66. And then the third, what's the equivalent of the, the fourth quadrant?
So that would be 294? Is that what you got?
Yeah, 270. No, 294 is correct. No.
So.
No, hold on. It's not 294. It's 36. Yeah, it is. Jesus. My math. 294. So those are the 4 angles in the unit circle. Now, can I do better than writing it like this? I don't think I can. In other words, I think I need both rows. How else could you write that? Is there any way to write that with one line only? I don't think so, because these aren't separated by 180.
Yes, sir.
In other words, the first angle you get when you make k equal 1 is 246.
Yes, sir.
And 246 does not show up there with any k, does it? No, it doesn't. So you need both rows here.
Yes, sir.
Same thing. Should we go on? If you want to do the problem, I will, but if you don't need to do the problem, I see a lot of tough problems on here that we probably want to cover.
All right, then let's go to one of the tougher ones.
In other words, that's a quadratic, right?
Yes, sir.
Quadratic and cosecant x. So you're going to do it the same way you did that one and do it the same way you did that one.
Yes, sir.
And in fact, that one's the same also.
Yes, sir.
And again, you just have to be careful about cosecant. Cosecant can never be between -1 and 1. It's always got to be greater than or equal to 1 or less than or equal to -1, just like secant.
That's right.
It sits on the tops of the sine, the tops and the bottoms of the sine curve.
Tangent and cotangent can be anything.
Yes. Well,
except for where they're undefined.
Yeah, tangent of pi over 2 is undefined.
That's right.
And the tangent of minus pi over 2 is undefined. And in fact, the tangent of k pi over 2 is undefined.
Yes, sir.
A vertical asymptote every pi. It's not, it's k times, it's pi over 2 times 180k, plus 180k, I think.
Yes, sir.
Okay, so let's see. Let's get into 7. Starts to get a little rougher here. Now, 7. What's your first thought when you look at 7?
I'm going to have to change these to a common trig function. Common trig.
Well, specifically what?
Would it be?
This is sine of 2x.
Sine of 2x. Oh. So we would use...
What's the identity for the double angle for sine of double angle?
Is that 2 sine x cosine x, or is that cosine 2x?
Oh, you got it. You got it. Now, cosine 2x, remember, has 3 answers.
Mm.
There are 3 identities, all of them important, for the cosine of 2x. So it's kind of special. Sine of 2x is the only identity I've ever seen. It's not to say there aren't others, but it's the only one I've ever seen.
Yes, sir.
Now what am I going to do?
So now you're going to, would you divide both sides by cosine of x?
There's a problem with doing that.
That's right.
And that is, if cosine of x can be 0, which it can be, then you're dividing both sides by something that can be 0. And when you do that, you lose that solution. Always. And it doesn't matter whether it's a polynomial or anything else. If I have that, what am I trying to say here? Yeah, like that. X to the 5th equals 6x.
That's, yes.
If you divide it both sides by x, you get x to the 4th equals 6, but you lose the 0 solution. And we can see that 0 has to be a solution there. 0 to the 5th is equal to 6 times 0. But
yes,
when I divide both sides by x, it goes away. I end up with only this. There's no 0 in that.
Yes, sir.
The answer is x is plus or minus the 4th root of 6. Well, so
yes,
you have to be careful, even when you're in trig, to not ever divide both sides of an equation by something that can be 0. If it can't be 0, you're okay. But
yes,
cosine can be. In other words, if this was secant, maybe we could do it, because secant can never be 0. So
yes,
how else can I solve this?
So
if I can't divide by cosine x, what can I do?
You would either divide by the coefficients or by the sine of x?
No, I would move this to the other side.
Oh.
And what's that going to do is allow us to now we can factor and we will not lose that zero solution. Because clearly pi over 2 is a solution. Cosine of pi over 2 is 0, cosine of pi over 2 is 0. So we don't want to lose that solution. And after moving everything over to the left, now we have a problem similar to one of these.
Oh, that's right.
So what am I going to do as the next step?
Factor out the cosine x and you get 2 sine x minus 3 equals 0. So cosine x equals 0. And sine of x.
This one cannot be right because sine can never be 3/2.
That's right.
So I'm going to throw that one out. Only one I'm going to look for is that one. Now where is the cosine equal to 0?
90 and 270.
And this is one where I believe you can use just one. In other words, I think you can do this.
90 plus 180.
Yeah.
Okay.
And that'll give you all your answers. Let's see, that'll give you 90, it'll give you 270, it'll give you 90, it'll give you 270. Yeah, so that works. All right. This one here, you can see we're going to do the same thing, only when we move sine of x over to the left, we're going to factor out a sine x instead of cosine like we did on the previous problem.
That's right.
Okay. What are we going to use on 9?
So on 9, would we use the sine sum formula?
That's what I would start with. So what is that? What's this term?
So that's going to be.
So the sine of x plus pi, pi plus x is going to be equal to what?
Sine of pi cosine x. Is that right, or do I have
Yes. No, you have it.
Yeah, sine of pi. Wait, what's the cosine sum formula? The cosine sum formula.
Here's the way to memorize it. The cosine of a plus b is cosine cosine minus sine sine.
Okay. And then the sine is sine of pi.
Still 2 sines and 2 cosines. That's the thing to remember. As long as, sine sine. Okay? And the reason they teach you this one first, oddly enough, is, I believe, because it's the easiest to remember. It starts out cosine cosine, opposite sine sine.
Yes, sir.
Okay? And then that makes it easier to remember the sine one, because the sine of a plus b, I know the answer's got to have 2 sines and 2 cosines, and I know it's split up. So it's got to be sine a cosine b. This sine is the same, not the opposite. And the only thing that could be over here, if I know there's 2 sines and 2 cosines, is it's got to be sine of b cosine a.
Yes, sir.
So.
So we got sine of pi, cosine of x.
Excuse me. Yeah, we're on the wrong one there. Okay, so I've got sine of pi, cosine of x, plus
sine. That's going to be plus.
What else?
Sine of x cosine pi.
All equals 2.
Yes, sir.
Now, what is the sine of pi equal to?
Sine of pi, that is equal to 1.
Nope. Tell you what, the best thing you can learn, Garrison,
Oh, wait. Sine of pi, that's 0.
memorize those curves. That one and the cosine one.
Yes,
Because
sir.
you're constantly asked the sine and cosine of these common angles. Constantly. So you don't want
Yes,
to
sir.
make mistakes there. In other words, you're dealing with some really difficult trig problems. This is the easy part here. So make sure
Yes, sir.
you know those two curves and you can draw them at will. Whoops.
Yes, sir.
Hold on, let's see. So the first term went away.
Yes, sir.
The second term was sine of x cosine of pi. What's cosine of pi?
So according to the curve, that looks like it is -1.
Yeah. So I've got -1 equals 2.
So there's no solution.
Correct. And you can kind of see why there would be no solution, because the sine of pi is always 0.
Yes, sir.
And I cannot add anything to it. In other words, if I treat pi plus x as a single angle, there's no way it
Yes,
can
sir.
be equal to 2. It can't be greater than 1 or less than 1. So I really didn't
Yes, sir.
need to apply any identities here. I could have looked at it and said, let's let pi plus x equal to theta. And now you got the sine of theta equals 2. Impossible.
Yes, sir.
No matter what x is. All right, let's try this next one. So give me the double angle formula for sine of 2x. That's the way I'm going to start it.
2 sine of x cosine of x.
And that's equal. What's secant of x?
Secant of x, that is 1 over cosine of x.
Which makes this, right?
So is that going to be infinitely many?
Good, very good. Yes, no matter what x is, that's equal to that.
Yes, sir.
Whenever you get an answer like that, where you just get one side of the equation matches the other and there's still a variable in there, that means that variable can be anything.
Yes, sir.
All right. The next one. I'm not going to go to the sum to product or product to sum unless I absolutely have to.
Yes, sir. Because we can just use.
I could use sum to product with that, and I could use it with that. But sum to product is very complicated, and I'm thinking the algebra's got to be easier if I just use the sum and difference formulas. So what's that become?
So that's going to be the sine of pi over 4 times the cosine of x plus the sine of x cosine of pi over 4 minus, and I'm just going to put this in parentheses, the sine of pi over 4 cosine of x minus the sine of x cosine of pi over 4.
Okay. Clearly that cancels.
Yes, sir.
And now you have 1 sine of x cosine of pi over 4 minus a negative, same thing. So I got 2 of them, right?
Yes, sir.
What's cosine of pi over 4?
Cosine of pi over 4 is, so that is 45 degrees. That's root 2 over 2.
Okay. So now I got 2 sine of x root 2 over 2, which is root 2 sine x.
That's right.
Equals 1.
So that is
Now what?
sine of x equals root 2 over 2. I think.
So what's x?
So x is 45
Plus?
plus. So is this going to be plus 90k?
180. Because
100.
actually two quadrants in the unit circle that work here. One is 45, the other is 135.
Because it's positive.
Correct. And incidentally, your calculator is only going to give you that one. So you have to know that sine is also positive in the second quadrant. In the second quadrant angle, it's equal to 45 degrees is 135.
Yes, sir. So 45 plus 180 and 135 plus 180.
Yeah.
Wait. 3? If it's only the first and second quadrant, then
360, yeah.
Yes,
we know it's always 360. Sometimes it can be reduced. But in this case, I'm not sure it can. In other words, the first angle we run into is 405 for the first one. And the first one we run into down here is 495.
Yes, sir.
And I don't get 495 no matter what I do to that.
Yes, sir.
I mean, if I do 180k, that doesn't give me a correct answer. That gives me 225, which is not correct. So I have to use both rows, and I have to use 360.
Yes, sir.
And the way you can always tell is just to run out. In other words, let k equal 1 and see if there is a simplified answer that would give you that same angle, and there isn't. In other words, I can't do 45 plus 180k because the very first answer I get is not a correct solution.
Yes, sir.
Okay.
Because the only difference, it has to be positive. It can't be negative. Adding 180.
180k is going to give me a negative.
Yes, sir.
Cosine or sine. Okay. I'm sure this is going to come out the same way.
Yes, sir. Probably.
Definitely use the positive or the sum difference identity. Should we go on?
Yes, sir. Yes, sir.
Okay. Especially if you have a test coming up soon. Although we're going to have one more session Thursday.
Yes, sir.
Okay.
Yes, sir. We are.
So what am I going to do on 13? Oh, this has its own new letter, 3B, huh? So this is different stuff.
Yes, sir. So it looks like, would we be able to cancel out the tan and cotan?
No, because the tan is of 2x and the cotan is of x.
That's right.
So let's start with the identity for that. We're almost certainly going to need the double angle identity.
The double angle identity of.
This is a little bit tough to memorize, although not really. Think in terms of, yeah, you just have to memorize it. It took me a long time to memorize it. It's tan of x plus tan of x. Well, it's 2 tan of x. Let's just write it like that.
Over 1
minus.
The
numerator is the same sign. In other words, I could have called this the tan of x plus x and used sum and difference formula. Well,
yes, sir.
When it's x plus x, then it's 2 tan of x in the numerator, and the denominator is tan of x times tan of x, so tan squared of x.
Yes, sir.
And now, if you convert the cotan of x to something, what do you get?
So 1 over 10x.
Which puts it there, and now I can cancel that with that.
Yes, sir.
So here's what I have. I have 2 in the numerator. I have 1 minus tan squared of x in the denominator. And all of that is equal to 3.
Yes, sir.
So where do we go now?
Multiply by the denominator on both sides. So
and
2 equals.
Safe doing that. In other words, tan of x can be 0. Got to be a little careful here because tan squared of x can be 1.
Yes, sir.
So by multiplying, actually, if something can be 0, you're safe in multiplying by it. You're
yes, sir.
not safe in dividing by it. So I can multiply both sides of the equation, and I get this. Now I get this. And now I get
root 3 over root 2. So I can plug that in. Right, plug it in.
Knowing that it's going to be all 4 quadrants whenever you see that plus or minus sign.
So around 51 degrees. So that's going to be
51 degrees. And what else for the plus side?
So that's going to be 51 plus 180. So that's 231.
Okay, and now for the minus side. What's the second quadrant?
129.
And the fourth quadrant?
309.
Now,
so 51.
Yeah, I believe we have to write this 2 ways. Maybe not. Hold on. Might be able to get away with just doing 51 plus... No, 51 plus 90 doesn't work. 51 plus K 180 doesn't work. So I've got to do X equals 51, hold on, plus K 180 gives you that one and that one, and it'll give you the next one. What's useful to know is the natural period of tangent is 180. It's not like sine and cosine. Natural period of sine is 360, also cosine.
Yes, sir.
Tangent repeats itself every 180. So you never need 360 times k when you're dealing with tangent.
Yes, sir.
And the other answer is 129 plus k times 180. And I think you need both of those. Yeah, because there'd be no way to get 129 from row 1 only.
Yes, sir.
right? And if k is 0, you get 51. If k is 1, you get 231. If k is 2, you get 51. So the only way to get this second row is with a second equation.
Yes, sir.
Hold on. Well, so far these aren't too bad. This one right there.
All right, 14. Sine squared of x plus cosine 2x is equal to the cosine of x. So would we use the cosine double angle formula?
Yeah, and let's go ahead and list them. Cosine of 2x equals what?
That is, isn't it cosine squared x plus, no, wait.
Minus sine squared x. And the reason you know it's minus and not plus is because cosine squared plus sine squared is always equal to 1. So it can't.
That's right.
Okay. And then there's a second one that defines it in terms of only cosine squared.
Cosine squared x minus.
And there's always a
2 cosine squared x minus 1.
And then the other one?
1 minus 2 sine squared x.
There you go. I'm pretty sure that that's correct. Are you looking at a book where you can check it?
That's what I remember.
Yeah, that's what I remember too. I've always had a time keeping those separate or distinguishing between those two. I always can remember number 1, and number 2, I'm never sure if the sine comes first or the cosine, and pretty sure last time I looked I said, oh, the cosine squared always comes first. So.
Yes, sir.
All right. So looking at this equation, which one of those am I going to use?
Looks like you would use 1 minus sine squared x. 2 sine squared x.
Well, then I'll have sine, cosine. In other words, ultimately you want the same trig function everywhere. It's easy to solve when you have a trig function. Or if you have a quadratic, that actually might work. But notice how well this works. Number 1.
Cosine squared x minus sine squared x.
Yeah,
and that
immediately you, well, let's do it. Hold on a second. I might be, yeah, no, I'm right. Here. So we got sine squared x plus, let's use number 1.
Yes, sir.
Number 1 identity. And you can see why I use it, because sine disappears.
Yes, sir.
So I'm left with cosine squared x equals cosine x.
Yes, sir.
How do I solve that?
So,
remember, you cannot divide both sides by something that could be 0.
Subtract by cosine of x and factor.
Yeah. So I end up getting cosine of x times cosine of x minus 1 equals 0. Oh, is it equal to 0? Where are we at? We're at number 14?
Yes, sir.
No, it's equal to, yeah. Okay. Yeah, I already moved this cosine x over. Yeah, okay, good. And so now your answers are what?
So that's going to be cosine of x is equal to 0. So that is 90 degrees, and 270 degrees, and then 0.
So how do I write this in a way that covers the entire range or domain?
So that 90 plus 180k.
I'm not sure we need the 180k. let's see. Yeah. Yep, that'll always give it to us.
And then 0 plus 360k.
Very, very good. And you do need, I think that's the only answer. Let's see. Does that cover all of our possible answers? We know the answers are 90, 180, 0, and 360, but not 270. So I could not just do 0 plus 90k.
180k.
Yeah, you gotta have, now hold on, I wrote this wrong, first of all. Here's our answers.
Yes,
yeah, I think you gotta write it like that. 90 plus 180k and 0 plus 360k.
Yes, sir.
All right, what else we got? 15, okay, this is...
So the absolute value of the sine of 1/2 x equals the absolute value of the cosine of x.
Well, obviously we're going to have to use which identity?
The half angle formula.
Okay, what is it for sine?
Is it the positive or negative square root of 1 plus the cosine of x
This
over
is
2?
another one I constantly forget. Here, I got it in front of me. I can look it up.
Or is it, it's either plus or minus?
It's minus.
Okay.
The cosine is plus.
Okay.
Okay. In other words,
Yes,
the cosine of 1/2 x is that same thing, only it's 1 plus cosine x.
Yes, sir.
So now I got this. Plus or minus the square root of 1 minus cosine x over 2. Absolute value of that equals cosine x. Absolute value of cosine x.
Yes, sir.
Now.
So we would have to...
Well, I can eliminate the absolute value on the left side, I think.
Is that right? Because it's positive or negative?
Yeah, in other words, if it comes out to be positive, it's still going to be positive. If it comes out to be this negative, it's still going to be positive. So I believe, they're always a little tricky, but I believe I can do this. Okay.
All right.
Now what's the next step?
So we would have to say that that is equal to the cosine of x and it is equal to the negative cosine of x.
Well, hold on a second. What's the next step going to be?
Would that be...
Ignore the absolute value sign on the other side for a moment.
Subtract it from that side.
How about
move
we
it to the other
square both sides?
Oh, square both sides.
Remember, you can multiply, you can square, you just can't divide by cosine x.
Yes, sir.
So if I square both sides, then the left side becomes 1 minus cosine x all over 2. What's the right side?
Yes, sir. Cosine of squared x.
Exactly, without the absolute value. Because
yes, sir.
Whether that's positive or negative, I'm squaring it, which is going to turn it positive, so I don't need the absolute value sign anymore.
That's right.
Now, it's probably worth finishing this just so we can kind of check it. So
yes,
I got 1 minus cosine x equals 2 cosine x. Move the cosine to the other side. I get 1 equals 3 cosine x. Cosine x equals 1/3.
And we can plug that in.
Yeah, give me an angle for that.
71.
And
289.
Now, if I was in the unit circle, I believe those would be the only two answers. And converting
Yes,
it
sir.
to a unlimited domain is not, we found out that's relatively easy. But I'm a little concerned that I haven't treated the absolute value correctly. First of all, if I take the absolute value of the sine of 1/2 71 degrees, I get a positive answer, right?
Yes, sir.
Same thing with cosine.
That's right.
I'm okay there. If I take 289, it's going to give me, well, half of 289 is second quadrant, 144.5. That's also positive.
Yes, sir.
Cosine of 289 is in the fourth quadrant. That's also positive. So I'm okay there. Now, the question is, have I left out an answer? In other words, is it possible that x could also be 109? Let's test that, because if that is an answer, then I need these other two angles. However, I don't, let's see, it'd be 109 and the second, and it would be 180 plus that. No, hold on. What am I doing here? It would be 180 plus 71. So there's the second and third quadrant angles.
Yes, sir.
Now let's see if those work. If those work, then I've done something wrong and I have to include that in my solution. But I don't think it's going to work. First of all, the sine of 109 divided by 2 is positive. And the cosine of 251 divided, excuse me, I'm not dividing it by 2. That's a third quadrant angle. That's going to be negative, but I'm taking the absolute value of it.
Yes, sir.
So I think both of these are answers. Now, I'm not quite sure what happened. When I did the algebra, my absolute value signs disappeared, but I wasn't totally comfortable doing that. And it's a good thing that I decided to check, because these two answers appear to be correct also. In other words, it's kind of like saying, if I would originally formulated the problem like this, I'll get all four of those answers.
Yes, sir.
And I guess you have to do that, because the way I did it didn't work. It only gave me the first and fourth quadrant answers. I'm quite certain that if you plug in 109, that will be an equation.
Yes, sir.
Let's just test it. What's the sine of 54.5 degrees?
Sine of 54.5, 0.814.
And we're taking the absolute value of that.
All right, so we have...
What is the cosine of 109?
The cosine of 109 is equal to... And we're taking the... Do you want me to give you the absolute value or just...
No? Just what you're...
Negative 0.3255.
Really?
Yes, sir.
So it's not an answer.
It does not appear to be.
No. So I was right the first time I did it. Neither one of those are going to work. I figured it was going to come out to be negative 0.814, which would have been true statement. but it's not. So I guess we did it correct in the first place.
I guess so.
Yeah. Okay. Like I said, these absolute values are a little tricky to deal with. Okay, 16. Let's see. Well, I guess we're done with today's session. I presume we'll be working on the same page next
Yes, sir.
Thursday. Okay. I'll just kind of remember we got through 15, and we'll start with 16 next time.
Yes, sir.
Okay. Garrison, have a good couple days. I'll talk to you Thursday.
Yes, sir. I will see you then.
Bye-bye.
Bye.